So far, we are working on the project alone and locally on our machine. However, most of the time, software is developed by teams where multiple people work on the same project. In such cases, how do people collaborate? Now, say a friend of mine wants to work with me on this project, and so she should be able to do the work on her machine. Now, in order to make that happen, I'll have to share my project with her. To share and collaborate on a Git-enabled repository, we need to keep a copy of our project at a central place where everyone can access it. Such a central platform is called a host, and the hosted copy of our project is called a remote repository. One of the most popular Git repository hosts is GitHub. So Git is a tool and GitHub is a service that we use to host Git repositories in order to collaborate with other people. It also acts as a backup in case something happens to our local machine. Alright, let's see this in action. So this is github.com. You will need to first create an account. I already have one, so I'm just going to log in. Once I log in, I want to host the project that we have been working on so far. To do that, we'll have to create a repo on GitHub first. I can create a new repo by clicking on this plus button and clicking on this new repository. Here, I can name the repo. So I want to call it Hello World. You can provide an optional description. For now, I'm going to keep it public so that anyone can see the repo. And I'm going to skip initializing with README for now. I'm going to just create this repo. Once I create this repo, you will see that GitHub tells us what to do next. This is the URL for this repo. There are two options. First one says, create a new repository on the command line. Second one says, push an existing repository from command line. So because we already have an existing repo on our local machine, which is the Hello World that we are working on, this is the one that applies to us. So it asks us to run this command. So let's copy this. Let's go ahead and run this. But let's dissect this. The keyword here is remote. In this case, this repository on GitHub here will be a remote repository for our local copy. This command will basically add a remote address in our local repository, which will point to github.com. Origin here is the default name of this remote. It's given so that we don't have to remember this long address. However, we can rename this to whatever we want. Also, a local repo can have multiple remotes. We can check all the remotes of this repo by running a command called git remote-v. Here we see two lines. Both of them are for origin pointing to the same URL, but one is for fetch and the other one is for push. Fetch meaning we can download changes from this remote repo, and push meaning we can upload our changes to this remote repo. Well, now that we have made a connection between our local repo and the remote repo, let's go ahead and upload all the changes that we have here on our local repo to our remote repo. The way we can do that is by running a command called git push origin master. Origin referring to this particular remote and master meaning to the master branch of remote. Because I'm already logged into GitHub via SSH, it doesn't ask me to authenticate. Otherwise, even on command line, you will have to authenticate with GitHub first. A link for setting up GitHub SSH is given in the link below. Well, now we have pushed all the changes that we had on our local master branch. Let's see what has changed on our remote repository. We go ahead and refresh it and we see that all the pages that we have here in our local repo has been transferred to our remote repository. We also see that the commit history that we had on our local repo has been transferred to the remote repository. By running git log, we can see another change that has happened. A new branch has come into existence here. This is called origin/master. This is a special branch called a remote tracking branch. For each branch that we push on a remote repo, a remote tracking branch is created. The job of this remote tracking branch is to tell us what the master branch looks like at origin. You can check them out like a normal branch, but it's recommended that you work on your local branch only. I'm going to switch to my local master here. When collaborating in a team, usually you wouldn't push to master directly. For each new feature or bug, you would create a branch, and once you are done working, you would request someone in your team to review, test, and merge the changes. This process in a remote repository happens via pull requests. Let's see that in action. In order to do that, we'll have to add a collaborator to our project. And guess what? Pochi also has a GitHub account. So let me add her as a collaborator in this project. I can go to Manage Access, invite a collaborator, Pochi. Here I'm logged in as Pochi and I can see the invite. I have accepted the invite. So now Pochi is added as a collaborator on our project. Now she will have write access on the repo, meaning she can directly make changes to this repo. Well, switching back to my profile, GitHub also provides a bunch of extra tools to make collaboration easy. One of the most important one is this tab here called Issues. An issue is made when we want to work on a feature, improvement, or bug fixes. So there are a few things we want to do in this project. First one is update our dog information. We can assign the issue to a particular person in team. And since Pochi is a collaborator on this one, the best one to work on this is Pochi herself. So I'm going to assign it to her and then submit the issue. So our issue has been created and been assigned to Pochi. Let's go ahead and add another issue. In our project, we don't see Alt Campus's website. So I'm going to create an issue called add Alt Campus's website address, and this I'm going to assign to myself. Well, I'm going to create the issue now. Well, now in order for Pochi to work on this project, she will have to make a copy of this remote repository on her local machine. Well, now I'm logged into Pochi's computer here. Now, in order for her to work on this project, she will have to make a copy of this remote repository on her local machine. The way she can do that is by making a clone. So I'm going to copy this remote URL and run the command called git clone and then the remote repository address. Once I do that, it says cloning into hello world. Now, if we go inside hello world, we see that the three files that we have here on remote are also present here. I'm logged in as Pochi here and she's going to start working on the issue that she has been assigned. So it says update our dog information. So I'll start working as Pochi on this feature here. Remember, I shouldn't push changes to master directly. So I'll first make a new branch. I can do that in one command by calling git checkout-b and making a new branch called Pochi. So now I have switched to Pochi branch. Here I'm going to do nano rdog.txt. And you know what? Pochi thinks she's not really the laziest dog. She just likes to take things slow. Okay, alright, we'll save this. And now we'll run a git status again. Here we see that rdog.txt has been changed, which is fine. We'll add it to the staging and then commit it. Now that she has made the commit, she will have to upload the changes to the remote repo. She will do that by running a command called git push origin and then the branch that she wants to push to, which is the Pochi branch itself. What this will do is that it will first create a new remote tracking branch called origin/Pochi and then push the changes to that branch. Once we have pushed it, we can do git log. We see that head has moved to the Pochi branch and origin/Pochi, the remote tracking branch, also points to the same commit. However, our master branch is one commit behind the Pochi branch because we just made a new commit. Alright, let's see these changes on our remote repository. Here we see that a new branch has been created under Pochi. This is the branch name Pochi. I'm logged in as Pochi here, and what I'll do is I'll create a pull request, meaning I want to make a request saying that I've worked on my feature and I want someone to review and merge it into master. This here is the name of the pull request and she can add further information on whatever she did in that repo. Say for example, updated my general attitude. She can create the pull request and assign someone to review it. So Pochi is going to ask me to review it. So a review request has been sent. And we can see all this information on this particular pull request thread here. Well, now let me switch back and work as myself. Alright, as a collaborator, I get a notification here saying that a review has been requested from me. So I'm going to click on this and I see that Pochi has sent a pull request. Basically, Pochi wants to merge the changes from Pochi branch into the master branch. So I'll go ahead and add my review here, which is Pochi has only changed one line. She has removed that line and said Pochi likes to take things slow. Well, I agree, so I'll just say looks good to me. And I'm approving these changes. So I've reviewed the pull request and I say that it looks good to me. And so I'm going to merge this pull request now. What this will do is that it will basically merge remote tracking branch named Pochi into the remote tracking branch named master. So I'm just going to do merge. So here I have merged the pull request successfully. Because this pull request has been merged successfully, I'm also going to delete the branch. Now, this issue here has been resolved. Because this issue has been resolved now, I can close this issue. Now, there's one more pending issue on our project, which is add alt campus's website, and this has been assigned to me. So I'm going to switch back into my role and start working on this issue. However, before we do that, let's look at the commit history at the remote repo. Here we see a commit that Pochi made about updating her information, followed by a commit that was created when I merged the pull request from Pochi's branch into remote master branch. A pull request merge always creates an explicit commit. Alright, let's start working on the issue that has been assigned to me. But before we do that, let's look at the log here. Here we have origin master and our master pointing to the same commit. However, we know that there are two more commits after the latest commit that we have on our local branch. That means our local branch is not really in sync with the remote branch. And that's because Git doesn't know about new commits that Pochi made to the remote repo. So to update, we need to get these new changes. We can do that by running a command called git fetch origin, meaning download all the changes from the remote repository. Let's run git log again. Running git log after fetching the changes reflects the right commit history, with origin master tracking branch being two commits ahead of our local master branch. So we would like to update our local master branch with the remote master branch. So we do that by running our merge command, git merge, but this time we want to merge origin / master branch into the master branch. So let's do git merge origin master. Well, it says fast forward, so this has been resolved by our fast forward merge, and rdog.txt should reflect the changes now, which Pochi likes to take things slow. Well, we can see the changes that Pochi made available to us on our local repository. Alright, now it's finally the time for me to start working on the issue that I have been assigned. So to do that, I'll go to my local repository and first make a new branch. I can do that by running git checkout-b and then the feature name. So this time I'm going to say alt campus website address being the name of the branch. Well, the command will create a branch and switch us to that particular branch. We can go to altcampus.txt and say alright, so I've added the website address of alt campus here. So that marks the end of that feature. So I'm first going to run a git status. Seeing that altcampus.txt has been modified, I'll need to first stage this and then commit it. Alright, so I made the commit. I still need to upload these changes to the remote repository. I'll do that by running git push origin and then the name of the branch that I want to push it to, which is alt campus website address. Once I do that, I can see that a new branch has been pushed. I'll go ahead, compare and pull, and basically issue a pull request saying that this is the work that I did in this particular pull request. I'm going to create a pull request and assign Pochi as the reviewer this time. Well, now I have made the changes, pushed them, and created a pull request, added Pochi as a reviewer. Now it's time for Pochi to review and merge my change. So I'm logged in as Pochi here. Pochi can look at this pull request and then go ahead and review this. Well, Pochi thinks this is fine, so she's going to approve the changes. Finally, she's going to merge my pull request into the master branch. Well, this has been successfully merged. Now, because this feature has been done, Pochi will go ahead and close this issue. So now we can see that we don't have any more pending issues. Let's clear it. I can check out master here I can run a git log again. This time it says that our master branch is behind our alt campus website address and origin alt campus website address branch by one commit. So again, we'll need to get the latest changes from the remote master branch. We can run git fetch origin and again git merge origin master, or we can combine that into one command by running git pull origin master. Git pull is a combination of git fetch and git merge. What it will do is that it will first download the changes from our remote tracking branch origin/master and then merge those changes into our local master branch. Alright, now we can look at our local master branch and we see that the website address has been updated and Pochi has also updated her information. Well, great. So in this example, we learned how to collaborate over GitHub.